This is section 1.3. This is the first part. We're actually going to take this section a little slow. This is how to solve linear systems by elimination. Before we do that, we do need to understand what equivalent linear relations are. Okay? So on the same grid, we're going to graph these two lines. X minus 2y equals 4 and 2x minus 4y equals 8. Can somebody tell me how I'm going to do that? How do I graph two lines? Yeah, Javed?
Put it in like the line format, like y equals mx plus b.
Yeah, I could do it that way. We could do it that way. Let's do it. Fine. We'll do minus 2y equals 4 minus x. And then we have y equals 4 minus x divided by negative 2. Y equals negative 2 plus 1/2 x. Y equals 1/2 x minus 2. Okay, that's one way. We're going to rearrange this one now. We have minus 4y equals 8.
Would you have to rearrange? Shouldn't it be 4 at the end?
Sorry?
It should be minus 2y equals x minus 4.
X minus 4. Here? You're talking about?
Top.
Up here?
Going low?
Here?
Yeah.
Yeah, minus 2y equals 4 minus x. I did that.
It's the same thing as mx plus b.
No, because I need y to be positive. Y equals mx plus b. I need it to be positive and can't have a 2. So that's why I divided out the 2, right? I divided the negative 2 from both sides. This crosses out. I get y, and then I'm dividing that by negative 2.
So my question, shouldn't the x be like where the 4 is and the 4 should be where the x is?
Yeah, I switched them out around at the end. Here. Okay, now we have this. I'm going to divide each by negative 4. This becomes y, and then I get negative 2 plus 1/2 x, and I get 1/2 x minus 2. So we can see just by rearranging that these are the same line, right? We can see that because the equation is identical. All right. I wouldn't have actually done it this way though. I wouldn't have rearranged it. It seemed to be a lot of work, right? I still have to graph it. I'm not done yet, right? It's a lot of work to do it this way. But we'll keep going. Okay. We know that the y-intercept for both of these lines, since it's the same line, is what? What is the y-intercept? RC? Negative 2, good. So negative 2 is on the y-axis here. All right. And now I know what is my slope. Stefan, what's the slope here of this line? What? What's the slope?
1/2.
Right? That's your slope, mx plus b. So what's the slope? Can you not see? You want to come closer?
Oh, 1/2?
Right, 1/2. So if this is a point on my line and my slope is 1/2, how would I go about graphing this? Daniel, do you know? No? Not sure? Adrian? Good. I rise 1 and I run 2. Right? Rise over run. So that is my second point. There's my line. All right, there's the line. Now, I said I wouldn't have done it this way. I was told you could do it this way. It was a lot of work to try and rearrange this. The other way you can find out this line is how? How can you find out how to draw a line? What's the other way? I taught you guys already. Rudy, do you remember how to graph a line if you have an equation?
Substitute.
Janir? Max.
Could substitute or eliminate.
You could do substitution. Elimination is what we're still learning, but there's another way. Yeah. Yeah, but we don't know the points yet. That's to get the slope. If you have 2 points on the line, we don't have that yet. You guys remember that we used the x and y intercepts? Do you remember this? Sorry?
Oh, is it like when you start at the y?
No, that's the way we did it. We started at the y-intercept. To use the x and y-intercepts, guys, we've gone over this, but you just sub in 0 for one of the variables, and that will give you the other intercept. So for the y-intercept, as an example, x is 0. So if I subbed in x equals 0 into this equation, I would get negative 2y equals 4, because x is 0. So we get y is equal to negative 2. All right, so that would have got my y-intercept right here, which we already know from the graph is correct. This one, next one, I would sub in y equals 0. So what would I get for x if I subbed in y equals 0? Daniel.
Ask the question again, sir.
What would I get for the value of x if I substituted y equals 0 in here? I'm going to write it out for you, okay, Daniel? Look. What do I get for the value of x?
Oh, what do you want?
Sorry?
What do you want to know?
No, not 1. What's 2 times 0, Daniel? Sorry?
Sir, could you explain it again?
Yeah, I'm asking you to solve this equation here, okay? So the only thing to do is 2 times 0. What do you get if you multiply 2 times 0? If you multiply anything by 0, what do we get? If we have nothing and we're trying... Sorry?
Same number.
No, that's 1, right? You multiply 2 times nothing, you're still going to have nothing, right? So 0. So we have x minus 0 equals 4. Now, what is x? Someone, are you laughing there, Rudy?
Me?
Yeah, who's laughing?
Oh, sir, I was sneezing.
Oh, you're sneezing, okay. X in this case here, we're gonna minus 0, x minus 0 is just x. So we get x equals what, Daniel? X equals? X equals 4, right. So that is on the graph here. You know, can you tell me where that point is? X equals 4, Douglas?
Say it again.
X equals 4. Where is that on the graph?
On the x-axis.
X-axis, good. Right here, right? So my 2 points then are here and here. So we have that line. I don't know if that was easier than rearranging the equation. I think for some of you it should have been, right? I think so. In any event, for both cases, you'll find that we get the same line. Okay, so how are the graphs related? Teodi, how are these two graphs related, these two lines? How are these two lines related, Teodi? This line and this line, how are they related? It's not a trick question. Andrew?
The same line.
They're the same line. How do I know they're the same line, Jaden? know how to make it more basic, guys. Milkias.
The slope and the y-intercept.
Right, the slope and the y-intercept are the same, so we know it's the same line. Yes, thank you. How are the equations related? So how are these two equations related? So we know that once we reduce them, they're the same. But how, before we reduced them, these two equations, how were they related? Yeah?
So
Ethan?
you asked how it was related?
Yeah.
You just divide it by 2, you can see that they're the same.
Right, so one way of saying that then is if I label them equation 1 and equation 2, I could say equation 2 is double equation 1. Does that make sense? 2 is double 1, right? We multiply 2 by the first one by 2, we get this. Does that make sense? Okay. So, what does it say here in big bold? Equivalent linear equations have the same graph. For any linear equation, an equivalent linear equation can be written by multiplying the equation by any real number. So what are we doing here? We're actually we're dissecting that video that we watched at the beginning, right? We're showing that if we multiply an equation, as long as we multiply both sides by any number, we don't change the actual line of that equation, right? As long as you multiply the left side and the right side, you can have that same equation be the same thing, right? That's exactly what's going on up here. This is the same as this. This is just multiplied by 2. So we don't change the line by doing that. All right, now that's important to understand because as we use the system of elimination, right, we're going to be multiplying these equations by numbers to try to cancel out in the other equation. So we don't want to change the line, we just want to change the numbers to make our math easy to cancel out. That's the whole point of this, okay? So we're going to write 2 equivalent equations for each of the following. Okay, so we can decide here. And pick a number. Who wants to pick a number for me? We're going to write 2 equations for this. Who wants to volunteer how we're going to do this? Rudy. 2. I love it. I love 2. Why do I love 2? Because it's the smallest whole number after 1, right? It's the easiest, right? So good. So we're going to label this equation 1 here. And now we're going to do equation 1 times 2. And Rudy, you're going to tell me what it is.
Okay, so 2 times 2 is 4. So x would be,
Doing this whole equation here times 2. Yep, 6x, good.
and then 4y,
Plus 4y, yep.
then
Equals? Yeah, good man. Beautiful. All right, that's 1. Okay, we want 2 equivalent equations. So this is equivalent to this. So what's another number we're going to pick? Stefan, pick a number.
4.
Okay, all right, let's do 4. We'll do 1 times 4. Okay, so keep going, Stefan. 3 times 4.
12.
Good. 12x. Yep. Plus 2 times 4.
8.
8y, good. And then 12 times 4.
28.
Good job. 48. All right, so is this equation any different from this equation?
No,
What do you guys think?
no.
No, there's no difference because we multiply the left side and the right side. That's the same as when we divide sides to sort of isolate variables. We're doing the same thing to every number, right? So we're not actually changing the equation. We're just manipulating it. We're moving things around and make it easier. Yeah, you said.
Are we allowed to divide 3x by
3x by 2?
2? Yeah, divide the whole.
You could. Yeah, we could. If you wanted a third equation here, you wanted to divide by 2, you could have 3 over 2x plus y equals 6. That would be equivalent as well. Right? But you're dealing with a fraction there. I don't know if you want to do that, if it's up to you, but. All right, next one. X plus y equals 4. Give me a number here, Daniel.
5.
Okay, 5. We're going to do 1 times 5, right? This is our equation 1. So what's x times 5?
You said does x represent 8? It represents 1, right? 8?
X represents x at this point. Doesn't represent anything. It's just x. It's the x value of the equation. So what would be 5 times x? You're not sure? 5x, okay? What would be 5 times y?
5
5y, good. And what would be 4 times 5? 20, good. All right, got one equation. This is equivalent to this. We've just multiplied everything by 5. All right, RC, give me another number. 2, I love it. Love 2. Super easy. 2 times x.
2x.
Tell me, keep going.
2y. 8.
Beautiful. Next one. 2 over 3. What would I multiply this one? Who's got a clever idea? Oh yes, Jeff, tell me.
Did you do 3?
Yes, I would do 3. Why would I do 3, Jaden? You know why? Do you know why Jafet and I both like the number 3 to multiply this whole equation by? No idea? No? RC?
Because it's on a thirds.
Yeah, and what happens when we multiply a fraction where it has a 3 on the denominator? We can do something cool. Yes, it magically goes away. So what is 3 times y, RC?
1. Which side?
Sorry? 3 times y.
Oh, 3 times y.
3y. And then 2/3 x times 3.
Oh, it becomes 1.5.
Nope. It's easier than that. Rudy, what's 2 over 3 x times 3? What? Yep, I'm timesing this 2/3 by 3. What's that? I was hoping it would be easy enough to do in your head. Look at this, Rudy, look. 3 over 1 times 2 over 3. What do we get?
6 over.
Two. Thank you. 2x. And then 1 times 3, Rudy? 3. All right. Here's my equation. Next, I'm going to do what? I got to multiply it by any number. Chenier, what number are you going to choose?
We're doing the fractional numbers.
We're doing this one still, yeah.
Can we do 6?
We could do 6, yeah. 6 is a good number. Okay, what am I going to get?
6.
What?
6y.
Good. 6y equals? Sorry? What'd you say?
4x.
Yeah, 4x. Good. Yeah, plus? No, 6 times 1.
Oh, 6.
Good. All right. Any questions? All we're doing there is taking a number of our choosing and multiplying it by the equation. That's all we're doing. I'm just taking the elimination process and we're breaking it down step by step. Douglas?
Yeah, how do you get a 4x?
4x? Oh, good question. All right, so he had 2/3 x times 6. This is what he had. Oh, I'll put the x on the top. Okay, so in this case, 3 and 6 cancel, so you get 1 times 2. So you just get 2 times 2, so you get 4x. That make sense? No? Let me do it again? All right, let's do it again. Okay. The dreaded fractions. 2/3 times 6 over 1. We get 12 over 3. We get 6. No. Sorry. What did I do? I messed up. 2/3 times 6. Oh, yeah, 12 divided by 3 is 4, my bad. Does that make sense?
Oh.
Yeah? Okay. All right. Which one of the following is not equivalent to the others? Ooh, a little mystery game here. Chenier, you got it? Tell me. Which one? This one is not the same as this one. So the way we would check that is to get our one of our variables to be the same. Okay? You tell me how you figured it out. How did you know that this was not equivalent to the other two?
Oh, okay. Yeah, you got me. I'm sorry.
Sorry?
You got me stuck.
I got you stuck? Okay. How can we figure this out? Rather than just guessing. Andrew, do you know?
Me?
Yeah.
Because if you multiply x times 2, it would be 2x. And if you multiply everything by 2, it
This
would
one?
yeah, for the first one it would be equal, but it wouldn't equal 0.
Okay, we're going to multiply everything by 2. We're going to get 4y minus 2x minus 8 equals 0. So what's that tell us?
Oh no, it is equal. So if
Yeah,
you move
this-
the 8's across.
This one, is it the same as this? It's close. I don't know.
No, it's not because the x is negative. Yeah,
Let's see. We get 4y minus 2x equals 8. Is this the same as this? It's not, right? Because the negative sign is different. Right? So if this is equation 1, this is 2, and this is 3, 1 is not equal to 3. Agreed?
yeah.
Yeah, Ethan?
If you multiply 2 by -4, you get the same equation as 1.
Okay, let's try it. So let's go 2 times -4. So we'll get -4y equals 2x plus 8.
So sorry, I wasn't right.
That is, ooh. Oh yeah, -4. This is -2. My bad. Yeah. So then we get 2x minus 4y equals 8. This is the same as this. So 1 is equal to 2. So which one of the following is not equivalent then?
3, sir.
3, yeah. Any questions with that one? Yep.
I'm wondering, do you think like you could like go over like some of the rules that you have to follow and like doing these steps?
The rules you have to follow for what?
Yeah, 'cause like that's the thing that that's
Sorry, I don't understand. Ask me again. What?
like on Monday I was asking if you could like very briefly you could go over like some of the rules that we have to follow in like getting like a line or something like graph like I know what I'm trying to say but I can't say it. It's okay, sir. I'll find a better option.
You want me to go over some of the rules that you need to follow to go from an equation to a line? On a graph? Is that what you're saying?
Yeah.
Okay, so I think that was section 1.1. If you go back there, you'll see my lesson. But one way to do it is to go by the x and y intercepts. So the way you do that is you sub in 0 for x, solve for y. That will be your y-intercept. And sub in 0 for y and solve for x. That's your x-intercept. So I kind of went over it with this problem right here. Okay? And then anything that you sort of don't remember, you got to go back in the lessons to review. Okay? You have this video too on YouTube to watch. Okay? All right. See if I can finish the first section of 1.3. Part B, equivalent linear system. So graph the linear system and find the point of intersection. So here we go. Shanir, we can go over it right now. We're going to graph these two lines. So what's the easiest way to graph? This one is already set up for us in y equals mx plus b. So I would use that method already. The slope is what here? Liam, what's the slope?
2.
And what's the y-intercept? Okay, so I'm going to start here at y equals 1. Okay. Now we're going to, what are we going to do? Our slope is 2. Yep.
You like rise to
Exactly, yeah. Rise 2, 1, 2, and then go over 1. Okay? So there's our line. We already have the first line done. Beautiful. That's our first line. Next line, y plus x equals 7. This is really easy to rearrange into form. Actually, this is even easier for our y-intercepts, right? Engineer, how can we get the x-intercept here? What do we do?
We can make y equal 0.
Right, so if we say y is equal to 0, because that's where it's on the x-axis, what is x? So here, y is 0, right? What's x? No, look at the equation. Y plus x equals 7. So if I cancel y, what's x?
Oh, 7.
7, yeah, right here. Okay? And now, Josiah, what is y intercept? How do I get y intercept?
Just 7 to every side, so 7 minus 7
Say it again?
would be 0. Move x to every side.
No, I wouldn't move x. I want to know the y-intercept, so I'm just going to set 0 for x.
Oh, yeah.
Does that make sense? So what's y?
So, 7.
Yeah, 7. 0 for x, y is 7 here. Okay. Here is my line. Yep. I don't have a tissue. You can go to the washroom if you need to. Yeah? All right. There's my 2 lines. What is the solution to this system of linear equations? Andrew.
2, 5.
2, 5. I love it. Yep. 2, 5. It's a fancy way of saying the point of intersection. Solution to the system of linear equation. All right. Now it says choose a number, any number. Choose a number. What number are we going to use?
Negative 6.
You want to use negative? Negative what?
6.
Okay. Negative 6. You're making it hard on us, Junior. Multiply the first equation in part A by the number. So what am I going to get in the first equation?
Multiply the first equation and
Yeah, so we're multiplying this here, Junior,
by 6.
by 6. What do I get?
Alright, so the first number is gonna be negative 12.
No, you got to do the y first.
Negative 6
Yep.
equals negative 12 plus
No. Negative 12 what?
negative 12x,
Okay.
plus 5.
6 times 1.
Oh, negative 7.
Negative 6 times 1.
Oh, damn, 6.
Negative 6 times 1.
Negative 6.
All right. Not sure what. Is there a reason you chose negative 6? Just make it hard, right? Like we like the number 2. You chose not only a high number but also negative. You made it really hard for everybody. How is the new equation related to the first equation in part A? So how is this equation related to this equation? Okay. How are they related? Yeah, Ethan?
Still the same.
Yeah, it's still the same line. Good.
We got all the same points right there.
Still the same line. Choose another number. Okay, I'm going to do this one. Let's choose 2. So I like 2. It's nice and easy. Multiply the second equation in part A by the number. So I'm going to get this equation here times 2. So I'm going to get 2y plus 2x equals 14. How is the new equation related to the second equation in part A? It is the same line. Okay, so what if I were to graph, or actually let me ask it this way. Rudy, what is the solution to the linear system, this and this? What is the solution? What's the point of intersection between this line and this line?
Is it? If it's both the same line, you have the same point, right?
Yeah.
Yeah, I don't know.
Sorry? Thought you
I don't
were.
know where the point would be, but it has the same point.
Okay, well, if this is the same line as this, and this is the same line as this, what's the point of intersection of these two lines? Yeah, right here, 2, 5. You said it yourself. If it's the same line, then it's going to have the same point of intersection, right? Okay, so it's right there. I was trying to trick you there, but it didn't work. Good job. If you graphed the two new equations that you obtained in parts A and B, what would you expect the point of intersection to be? That's the exact question I asked. Look at that. So, the answer is, Teody? Caught you asleep. If I graph this line and this line, Teody, what would you expect the point of intersection to be? Right. 2, 5. The same POI. Point of intersection. Okay. Ooh, I can finish this. Come on, 5 minutes. Here we go. I'm going to go a little bit quick here. Graph the linear system to find the point of intersection. Okay, so again, we have very easy graph here. I'm going to do this by point x and y intercepts because I find that's the easiest. Here I'm going to say y is 0, so my x is 4. The next one I'm going to say x is 0, so my y is 2. There's my first line. My second line, x is 0, y is negative 1. Here, y is 0, x is 1. My second line. Okay? If you add the left sides and the right sides of the two equations in part A, so the left sides and the right sides, you obtain the equation 2x plus y equals 5. So if I'm adding these two up, graph this equation on the same grid as in part A. What do you find? Okay, so it wants me to graph this now. So I'm going to say y is 0. My x is going to be 5 divided by 2, which is 2.5. So my x is 2.5 right here. Next, I'm going to say x is 0, so my y is 5 right here. Okay, so I get this line. Okay, if I add those two